Hello, welcome to my presentation. I'm Shen Siyu. My research topic is price analysis and prediction for Airbnb listing in Bangkok. First, I will introduce the abstract of the research to you, so you can quickly understand the content of the research. As tourism in Bangkok, Thailand continues to grow, more and more travelers are choosing to stay at Airbnb. The rapid development of Airbnb in Bangkok has brought significant challenges to pricing. Unclear pricing standards often lead to poor income for hosts and difficult decision-making for tourists. This study addressed these challenges by developing a machine learning-based model to predict Airbnb listing price and combining it with a post-model evaluation technique, SHAP, to explore the factors behind the price. The results shows that XGBoost won the champion model with the lowest MAE and RMSE. Explainability analysis shows that the distance from the city center, the number of bedrooms, reviews, and amenities are the most important factors in determining the listing price. Host travelers and Airbnb platform can benefit from the research finding. In the context of rapid development of tourism in Thailand, the rapid development of Airbnb has also brought some problems, especially in terms of pricing strategy. For hosts, there's no market reference when pricing. For tourists, there's no clear evaluation standard for price. And for the Airbnb platform, chaotic pricing not only affects the user experience, but may even affect the company's revenue. The purpose of this study is to develop a machine learning model that can accurately predict the price of Airbnb listing in Bangkok. And SHAP is used to explainability analysis to reveal the key drivers behind the price. In recent years, some researchers have studied various aspects of Airbnb, including its impact on the economy and regulations. Some have studied the factors that affect price, but current research methods mainly focus on statistical methods, such as regression analysis and descriptive statistics. Although some studies have begun to apply machine learning to analysis, these applications are mostly focused on classification problems rather than regression problems. Finally, existing research rarely involves explainability analysis of machine learning models. Therefore, this study will try to fill the previous gap. Here is the workflow of this study, starting with data collection. The dataset I used the Bangkok data of Inside Airbnb on June 26, 2024, followed by data cleaning, including data filtering, missing value handling, and noise removal. Feature engineering includes creating new features, feature selection, feature encoding, and standardization. Then hyperparameter optimization and model training. Finally, model evaluation, expandability analysis, and conclusion. Next is the descriptive analysis. These two maps shows the distribution of Airbnb listing in Bangkok under different dimensions. The map on the left shows the distribution of different room types. And the home or apartment are mainly located in the city center, which also reflects that most travelers prefer to stay in the city center. On the other hand, private rooms are more evenly distributed across the city. The map on the right shows the distribution of price in the city. Obviously, high-priced listings are concentrated in the city center, especially the commercial center, while low-priced listings are mainly distributed in the surrounding areas. In the data cleaning part, I first excluded new listings because reviews are also an important analysis indicator. Then I excluded unbookable listings and listings that require a minimum stay of more than 1 week, because the goal of this study is to analyze the target listings for short-term travelers. Then I processed the missing value and removed the noise. I used the ACA method to remove the data that exceeded a certain price range, and then bedrooms, number of reviews, and review score rating according to the histogram. It can be seen that these data are concentrated in a specific range, so they were processed. For feature engineering, I created 7 new variables: host years, distance from city center. According to similarity, All amenities were regrouped into four groups: comfort and basics, appliances and technology, safety and facilities, and convenience. For the description field, it contains multiple languages, such as English, Thai, and Chinese. It is difficult to compare the content, so it is converted to measure the length of the UTF-8 character encoding. In the feature selection stage, the price column will be set as the prediction target. For other columns, many columns are divided into summary columns and detail columns. For example, the review score is divided into the total score and the individual scores. Therefore, to avoid feature duplication, I use the summary columns. In addition, the ID, name, and URL columns will not be selected. I also performed the correlation and VIF test, and the host response time variable was removed because of high correlation and VIF. After one hot encoding of the multi-classification variables, data splitting is performed. The data will be split into training set and test set in a ratio of 80% and 20%. The specific operation process is to first standardize the training set and then apply this statistic to the test set. The purpose is to prevent data leakage. I selected four machine learning algorithms for model training: SVR, random forest, XGBoost, and LightGBM. The reason for selecting two boosting algorithms is to compare the differences between the classic algorithm and the new algorithm. In order to find the best hyperparameter combination of the model, I used the Grid Search CV with 5-fold cross-validation. Grid Search CV is an exhaustive search method that tracks all parameter combinations within a parameter grid, and use cross-validation to evaluate the performance of each combination. The evaluation indicator is MAE. From the prediction results, XGBoost has the lowest MAE and RMSE among these four models, which means it has higher accuracy and prediction ability than other models. Therefore, I choose XGBoost as the champion model. On the other hand, IGBM only took 0.37 seconds to complete the model training, which is shorter than other models. In the explainability analysis section, I show two shape results figures. The left one explains the sample with the median prediction value, and the right one is the global explanation. The baseline value EFX represents the average prediction of the model. The final prediction for this sample is Fx. From this single sample, we can see all three people to stay has a positive impact of 308 on the prediction price, and the large number of reviews increases by 151. In contrast, being far from the city center reduced its predict price by 298, and having no bedrooms reduced it by 154. Focusing on the global explanation, the distance from the city center has the greatest impact. The bedrooms and accommodation capacity also have significant effects, reflecting the importance customers place on the space and group accommodation. Many amenities also have a great impact on the prediction, especially safety facilities, which contribute 103 to shape value. In addition, review also play an important role. After applying the post-model evaluation technique to the champion model, the key factors affecting the price prediction were comprehensively analyzed, which improved the transparency of the results. For Airbnb hosts, a data-driven pricing approach is provided. For travelers, the model's predictions can help them find the best listing for their budget. For Airbnb platform, the results of this study can be used to optimize their recommendation algorithms. Finally, the study has certain limitations. The dataset may not fully reflect future market dynamics, and its applicability in other cities has not been verified. So, the higher availability of this model will be explored in the future. Okay, thanks for watching.